Hi, this is Hector with Alphacam, and today we're going to be looking at how you can leverage the power of Alphacam Advanced or Ultimate Router to achieve incredible flexibility and productivity when it comes to nesting parametric files. We're going to be harnessing the power of Alphacam through the use of a custom utility known as hCAM. At any rate, to get started so that you can understand the process, I'm going to go ahead and let you know that AlphaCam already has the ability to let you define parametric sketching via a technology we call constraints. Constraints will allow you to go ahead and define a drawing and alter any of the parameters that control this drawing. For example, right now I'm changing the size of this door. I hit apply or enter and I can automatically resketch it. Right, so I can go 24, I can go 14 or 12 and a quarter, it doesn't matter. Set this back to 2 and a quarter, and then I can go ahead and hit tab and enter, and then you can see that the door is automatically resketched. Now, um, AlphaCam therefore has already helped you automate the process of drafting. The next thing AlphaCam allows you to automate is the fabrication of any of these elements by letting you define knowledge-based containers of tooling information that we call the machining styles. The machining styles allow you to quickly and efficiently store and apply different tool sets or tool decisions to a particular object. So when I go ahead and I do that, I can very quickly go ahead and create complex toolpath data for an object very quickly and efficiently. So if we start understanding what this technology does, we have the ability to have cascading tools and different profiles work directly on any object. This example, of course, is very well suited for MDF doors. So if we continue to talk about the example of the MDF door, we'll see that we also have a particular challenge, which is what we call backside operations. Backside operations are going to be achievable by simply putting any operation that you want to put on the backside in a different layer. You can see here that I've got different machining assigned to different layers. For example, I've got a profile layer. This would be for the top side operation of the sheet. This is an outside layer that actually squares the door out, and I've got backside operations sitting on a layer of that name. The name of the layer is completely inconsequential, but it should illustrate what we're hoping to achieve here. Likewise, just like before, I have a machining style that I'm calling backside operations, and when I apply it, I have the ability to target only the things that I want to do, though in the way in which I want to do them. And you're going to see that on the backside operations, we are going to be pocketing 35 millimeter hinge cups. We're going to be making some pockets so that we can put a recessed glass insert in this door, and we're going to be finally cutting out this door. Okay, so now where does hCAM come into play? hCAM is a utility that will allow you to define with great control and granularity all of the different options that you have for the fabrication of these parts. You can have multiple machines that you can send code to automatically in cascading order. You can see that you can select your post processor. You can select a folder that you're targeting for your G code. You can also select a folder where you're getting your machining styles from. We have support for multi-drill. We also have the ability to trigger reports, run queries. This is interesting. This is the section of the utility that allows you to tell hCAM how you're going to be importing your door data from a CSV file. These are all the nesting options that we support. Interesting and predominant importance would be right now that you have the ability to define rectangular nesting and allow hCAM through the power of AlphaCam to select the best sheet for your nest. This is going to be very interesting because you will get the utmost savings in material. I'll show you in a second how you can go ahead and define your material database. You have your gap between your part and your gap at the edge of the sheet. We also have the ability to square off the sheets. We have support for bridge part nesting, intelligent onion skinning, intelligent tagging. This is a data table where you can assign all your different machining styles to your specific layers. Here we have the profile and the outside layer, which we're going to be working with right now. And we also have the ability to ignore a certain set of layers, which are going to be important for the top side operations. So, regardless of the amount of settings, we also have the ability to define a sheet database, which is a collection of data tables which can easily be read from SQL. You can see that we have material sizes that we can define, and these material sizes can change, and hCAM is going to pick these sheets by quantity, and it will allow you to have combinations, even off-falls of material, based on whatever is most advantageous or most economic for the job. So hCAM is going to allow you to read, just like it says over here, a CSV, a text file, or an XML file. Before we open that up, I want to go ahead and show you the contents of the file, which is located over here in the same job folder where I have my two parametric files. If I open it up, you will see that there's really nothing to it. It's just the name of the material, a description for the file, length, width, and thickness, quantity, a path to the location of that particular file, priority if it's important to you, and whether you're going to allow rotation on this particular material or not. And now here's how hCAM handles your parameters. In your COM separated file, you can put the name of the parameter that you're pushing in the file, the equal sign, and then the value for that. And literally there is an unlimited number of parameters that you can pass to your files through this mechanism. hCAM does not restrict you as to how many parameters you can pass. So having said that, we're going to go ahead and go into hCAM, and we're going to open up the job file, which is this one here. Job information screen comes up. I'm going to call it nested or MDF doors. Customer name none, programmer Hector, PO number 123456, notes, no notes. And so when I click OK, hCAM reads the contents of the CSV file and immediately generates data tables and dumps that information so that the user can select them. You can see that we can select and deselect material. We have the ability to affect the quantity multiplier, which multiplies by a specific integer the quantity. This information is read-only. Right now, if I were to change the size, it wouldn't actually change the size of your door or your parametric file. To do that, we have to open up the CSV file one more time. But I have access, for example, to my configuration settings right here. I also have access to my sheet database right here if I need to make any changes. I can merge jobs located right here. I could, for example, get another CSV file and put it in here. At any rate, without further ado, what's going to happen is this. We're going to hit run, and you're going to see in the background, the first thing that's going to happen is, well, you have the ability, like I said before, to run multiple configurations. This usually can translate very easily into you're running multiple machining centers and you want to generate code from multiple machines back to back. Or, for example, you have operations you want to send to nesting machines and operations that you want to send to point-to-point machines. All of the setups allow you to go ahead and do that expeditiously. Right now I'm just running one setup, which is a parametric nester. When I do that, hCAM begins the process of opening up each one of those doors in the CSV file, stretches the door, applies your machining per your machining style, and then saves the door. Now you can see that we have an information screen letting us know that we are running part number 11 of 13. Now the processing happens significantly faster. I had to slow it down for the presentation. You can see we're nesting multiple material sizes, but the algorithm is going to pick the best possible material for the job. Okay, at this point in time, the job is complete. The nesting algorithm continues. We are now generating reports automatically, which is also leveraging the power of Alphacam. We have the ability to generate reports and labels, right, for your different jobs. Here you see that. Now what's also happening here is we're optimizing the tools. We're generating the best possible sequence for your machining. And then we're going to generate the G-code for the top side. So now immediately after the generation of the G-code for the top side, you will see that we do the reverse side nesting. This is when the software is going to completely generate a mirror of the part, add the backside operations, and generate the code. If we quickly take a look at what are the results that we got out of the software, you'll see that of course we have all of the drawings for the top face, which is what we've got here. We also have all of the drawings for the mirrored side, which we have here. And I purposely put a combination of things that do need heavy operations in the back and things that only need to get cut out. This of course is user defined. What I was trying to do here is get into a rhythm of, you know, you always flip every sheet, but this is of course not a necessity. Now if we go back to the folder, you will see that we've also generated an individual file for every one of the doors, so you can take a look at that, scrutinize it, and potentially generate G-code for it. Also, hCAM can generate G-code for every individual part if the user desires. Now let's also analyze what happened in our G-code folder. You have, of course, a folder with the name of the job, which is MDF doors. Then you have a folder with the name of the setup. Remember that this is similar to having a folder for every one of the machining centers you're sending information to. So this could be, I don't know, a Morbidelli machine, and this could also be a Wiki machine, and this could also be a Shota machine. You would have a folder for every one of those. Inside of that, you have a folder for the material, and then finally, we've got all our different G-code files for the top side as well as the mirrored side. Well, I hope this has been informative. My email is hector@alphacamtraining.com. If you have any questions, please shoot me an email. Thank you.